Good. So what is the first element of the periodic table? Hydrogen. Good. We go to what? Good. And we follow by lithium, boron, good. Phosphorus, chlorine, potassium, calcium. Good. So these are the 21st element of the periodic table. But for us at your level, and I didn't get a chance to get a touch on your syllabus, there's also a couple of elements that are getting tested at your level, and I kind of saw it yesterday. You need to know the other elements that kind of drop down in this group. So what do we have here? Bromine and iodine, right? So you kind of have to know that. And what about here? So what do you have in group 1? Tell me. Rubidium, okay. Good. Good. So in the middle here, we have what? We have complex metals, right? So those ones, I kind of came up with a song back in college. I don't know if it's going to make any sense to you guys, but you're always going to get the periodic table most of it. But how I remember the elements here is like since theta, vomit, koro, man, fear, cook, one side cook, near, copper, and zinc. Is that correct? Yes, sir. Okay. Is V what? We know that what? In the periodic table, we have our metals here. You have your earth metal. What I wanted you guys to do as you are revising into the GC, like identify all the properties of the periodic table. We'll talk of atomic radii. We'll talk of like ionic size. We'll talk of solubility, right? Good. So as you are filling the elements of the periodic table, you are adding elements to what? The outermost shells, right? So you have to go back and understand those principles and tell yourself. So let's try to write a couple of these elements down, starting with lithium, beryllium, boron, carbon, and kind of see how their properties vary across the periodic table. So what is the electronic configuration of lithium? Good. And this becomes what? 1s2, 2s2. Then you have 2s2, 2p, 2p1. Then you have 2s2, 2p2. Then you have 2s2, 2p3. Good. So what I did is that, remember the s orbital is just what? 2 electrons, right? And the p orbitals can accommodate up to 6. Good. So anytime I'm giving a question as to account for either ionic side or atomic radii, the first thing is you have to know is that if it's just an atom, it's just the electronic configuration. You kind of have to visualize, are electrons experiencing what we call electron-electron pair repulsion, making the atom bigger than the previous one? Or are they experiencing, is the last electron coming into an empty shell where it's just making the atom smaller? The thing you have to understand is that what? When you go from left to right for metals, what happens? Can anyone tell me what is happening when I'm going from lithium to beryllium, or from sodium to magnesium, or potassium to calcium? The number of electrons and the number of protons that you have in the nucleus equal in the neutral atom. Is that correct? Good. So let me take an example. If I have 3 electrons here, 1, 2, 3, I also have 3 protons. When you move here, if I have 4 electrons, I also have 4 protons in the nucleus. But remember, for every electron that you add to the atom, the positive charge moving across the period is stronger. So if they are attracting those electrons stronger, so this is what happens for metals. Then when you go over to non-metals, what happened? Remember, we said there what? The size decreases on this size. Why? Because of the... exactly. Good. So anytime you are taking an electron, you need to ask yourself, do that remaining ion has achieved a valency? That is, does it resemble one of the noble gases? If that ion has reached one of the state of the noble gases, it means it's very stable. That is what happens with group 1 ions. If you just take these, remember it's just one S2 left, which is equivalent to neon, right? Or helium, sorry. So it's achieved something that we call a valency state or a stable state. So for you to remove a second ion from that element, it's going to take a lot of strength, a lot of energy. That's what when someone mentioned lattice enthalpy earlier, you have to understand, same thing happened for beryllium or like sodium and magnesium. If I'm taking an electron here, right? Good, there's one electron left in that orbital. But the next, so beryllium plus is what? 1s2, 2s1. So that is still very unstable. So you see, the energy needed to take that second electron from beryllium is not as great because that atom actually wants to get rid of it to look more like helium instead of keeping it. So what we did today was kind of a quick revision and a quick brainstorming of different concepts across the periodic table. So what I was trying to kind of address after watching their teacher yesterday, we'll kind of try to integrate different concepts that I think most students kind of put together at this moment. So they have a good understanding of different topics in chemistry across the board, but most testing or exams try to integrate those topics together to kind of help you pull knowledge from different notions and kind of apply it to like real life scenarios. And I think that is what education is now becoming, and I think that is what is gonna be going down the road. And also we kind of just try to kind of give them advice of what I think they should do going forward while studying for their GC or like government common entrance examination.